And thanks for joining us to this webinar. My name is George, and I will be joined by Francis Atkinson, my colleague here at the ChEMBL group. I will go through the slides and the live demo of the webinar, and Francis will try to answer questions that you may have via the chat box today. So we both work at the ChEMBL group, and what we do at the ChEMBL group is we manually extract chemistry and the bioactivity data from the primary medicinal chemistry literature. And then what we do, we organize, integrate, annotate, and further curate the data. And then we add value to the data, and we provide the data back to the community in the form of insights, tools, and resources that hopefully accelerate and facilitate contemporary drug discovery. So there are lots of ways to access the ChEMBL data, the structural activity relationship data, depending on the use case and the application. So these different ways to access the data range from straightforward and intuitive website access, web services, semantic web technologies, database technologies, and finally the virtual machine. And today at this webinar, we would like to focus on the virtual machine called myChEMBL as a way to access the data in ChEMBL and much more. So what is myChEMBL? myChEMBL, as I said, is a virtual machine which is loaded with a complete version of the ChEMBL database. That's ChEMBL version 19 at the moment. And then using the database, it's chemically aware, so you can do a number of chemistry searches against it. And it also has its own user interface and its own web services to access the database programmatically. In addition to the ChEMBL database, myChEMBL has a range of cheminformatics and data analysis and mining tools, such as the RDKit cheminformatics toolkit, and then several Python libraries for scientific computing, such as iPython, Pandas, scikit-learn, NumPy, etc. And finally, the third aspect of myChEMBL is a number of tutorials, iPython notebook tutorials on a range of topics, from cheminformatics, machine learning, data mining, to web development. Finally, myChEMBL follows the ChEMBL updates. So at the moment, the ChEMBL version is 20, and very soon a new myChEMBL version is going to be released, having ChEMBL 20 in the virtual machine. So what are the advantages of using myChEMBL as a way to access ChEMBL data? First of all, as all the resources that we provide is free and open, so there is no cost, and that's because myChEMBL uses only open source and free libraries. Secondly, it's the security. So myChEMBL runs locally behind your firewall, so you can access it offline, even via your laptop, on a train, on a plane, etc. And that's very convenient for people who are hesitant to use web services and send queries over the internet. Thirdly, myChEMBL is very easy to use. It's very intuitive because all the applications around myChEMBL are web-based, and they have their own graphical user interface. So if users don't wish to interfere and interact with command line tools, they can do so. They can just use the web-based applications, which are very intuitive and interactive. Finally, myChEMBL is an all-in-one self-contained solution. It's got the data, it's got the tools to analyze the data, and it also has the tutorials to show how people can use these tools to analyze the data and derive their own applications. So talking about applications, what can you do with myChEMBL? So myChEMBL can serve as a centralized resource for data and services. For example, imagine you work in a small group where each one of you has their own version of ChEMBL, their own version of Python, RDKit, etc. This can very quickly lead to conflicts. On the other hand, myChEMBL provides access to standardized tools services and data, so you can all access exactly the same versions of the tools and the data. Secondly, you can use myChEMBL for application development. If you are a cheminformatician or if you're a developer, all the source code is available. The virtual machine is sandboxed, so you can very quickly start developing your own apps. Furthermore, myChEMBL is very useful for learning because as everything is pre-installed and pre-configured, the user does not have to install and configure the tools or maintain them. So it's really easy to just start playing with data mining, data science, cheminformatics and bioinformatics without having to worry about installations and maintenance, etc. The other aspect of myChEMBL as an additional application is the teaching and training. So as I said, myChEMBL includes a number of iPython notebooks, a very intuitive and interactive way to go through programming and show workflows and share the workflows with other people. And also myChEMBL includes 9 workflows. Again, 9 other a workflow tool that allows people to share workflows, share the logic, go through computational experiments. And we also use myChEMBL extensively in the annual course on computational drug discovery that we organize here at the EBI in collaboration with the Wellcome Trust. And myChEMBL has been a very valuable resource for teaching. Finally, another application that myChEMBL would be very useful at is reproducibility. So that's reproducibility of algorithms and methods and computational in silico experiments. And that's very important because science is not just about writing and publishing papers, it's about sharing the results and building on top of the work of other people. So myChEMBL is a platform with standardized data and tools, so it could be used as a platform for reproducibility, allowing people to share the results, share algorithms, giving the opportunity to other people to evaluate and test these algorithms and then build on top of these. Right, so what are the key technologies behind the myChEMBL virtual machine? First of all, it's the Oracle VirtualBox. So this is the software that you would use to import the VM and then launch the VM. It supports all major platforms, so Windows, Mac, and Linux, and it's free to download and use. The operating system that runs the virtual machine is Ubuntu. But users don't need to interact with Ubuntu if they don't want to, so they don't have to worry about maintaining or updating or using the command line at all. And then finally, the database that we use to store the ChEMBL data and also facilitate the chemical searches is the Postgres database. Further on, I mentioned RDKit. RDKit is an open source cheminformatics toolkit. This is at the heart of myChEMBL. It deals with the chemical searches via its own cartridge, a Postgres cartridge in the Postgres database. But it also has a lot of other functionality. So it deals with mol files and smarts and smiles, reaction, fingerprints, molecular properties, structure rendering, force fields, etc. It's a very mature cheminformatics toolkit, and it's provided free. It's freely available, and it has a very vibrant, a very active user community. The other aspect and the other key technology that we use in myChEMBL is the iPython notebook. That's the technology that we use to provide the interactive tutorials. I'm going to give a live demo of this actually, so I'm going to talk about this further on. And finally, as I said, we use several other Python libraries, and also tools and toolkits such as OSO and the JSME molecular sketcher, KNIME, Vagrant, VMware, etc. So this is the slide that explains what the iPython notebook is. So it's an interactive tool to write code, in this case Python, but nowadays you can use other languages. You can write code on a browser, and this is very convenient because it combines the code execution, the results of the code execution, and it also combines it with plots, images, JavaScript, markup, HTML, etc. And what is very useful is that you can share these notebooks or host them online. So it's a form of literate programming, combining the code along with documentation and text and plots, etc. So once you have myChEMBL up and running, you can go to your browser of your host machine and then go to a predefined URL, and this is what you will see. A launchpad with different links, and during the live demo we will go through all these links, and I will give you a quick example of how you would take advantage of each one of these. And in terms of installation, what you have to do to install myChEMBL locally to your machine or your server would be to go to the FTP, download the VM files, also read very carefully the installation instructions, and then you can import the files in your VirtualBox, and then after maybe 10 minutes the virtual machine will be ready to use. For the people who are more familiar with command line tools, or they are developers, there is also a Vagrant installation available. You will find more details on our blog post if you follow this link. And finally, the whole project is available on GitHub. There you will find all the scripts for the installation of the virtual machine. You will find the iPython notebooks, and also you will find a section where we record and document ideas for further development, and you're welcome to contribute there and share your ideas for further development and improvement of myChEMBL. So moving on to the demo of myChEMBL. So let me first show you how you would install myChEMBL yourself. So we'll go here. So this is the main ChEMBL page. If you go to downloads and then myChEMBL and then current, so from here you can download the 3 files. I guess the main file is 9 GB big, so you'd have to wait a bit. And then during this time you could also have a look at the installation file here, make sure everything is in place. And then, as I said, it will take maybe 10 to 15 minutes for VirtualBox to import the files to your host machine. And then after that, once you launch VirtualBox here, you will see myChEMBL 19 in the list of your virtual machines. And then from there, you can just do start. And now you will see the virtual machine that is launching. So it asks for my credentials, and these are ChEMBL, and the password is ChEMBL VM. There you go. So this is the prompt for the Ubuntu operating system. If you want, you don't have to use the prompt. So if you go back to the browser of your host machine, you can go to the predefined URL. In this case, it is 192.168.56.101, and you'll be presented with the launchpad or myChEMBL. So these are the different links, the different ways to interact with the data and the tools stored in myChEMBL. So the first way to access the data, and the most, I guess, intuitive, is the web interface. So myChEMBL has its own web interface where you could do your own similarity searches and substructure searches and browse the results. So for example, structure search, let's say similarity, let's say draw structure, so I can draw a structure here. And I can do a similarity search against the ChEMBL database, and that's the results of my search. And for this search, it used the RDKit cartridge and the database inside myChEMBL. So there was no external web service request to the internet. So everything was local between your host machine and the virtual machine. So going back to the Launchpad, the other way to interact with the data would be to query the database directly. So we have here another tool. It's a tool that it's a database browser effectively, but it's a web-based one. So you can connect directly to the Postgres database that runs inside myChEMBL, and you can browse the schema. You can browse all the tables here. You can see the columns, and then you can start writing your own queries using SQL. For example, if you click, so if you click the SQL tab, you can write a simple query. Click execute, and then you will see the contents of the source table. You can download the results, for example, or you can try a more sophisticated query, joining different tables, getting the results, and then exporting the results into a CSV, for example. Again, going back to the Launchpad, the other way to access the data would be, besides the web interface and the direct access to the database, would be via web services. So again, if you click this link, there is a live documentation of all the different methods that myChEMBL provides as web services. So these are the web services that use the ChEMBL data. So you can do a chemistry search, so a similarity search or a substructure search via web service, or you can fetch data for any compound, target, or assay you wish, and that's programmatically. So you can use 9, for example, to fetch the data, or you can use Python or Perl, and we have also our own Python client that's available and you can use in order to use these web services. And again, these web services use the data that are within myChEMBL. So in addition to the web services that fetch ChEMBL data, we have another set of web services which provide Bioinformatics services. We call these web services BigCare. So for example, in Bioinformatics, people do very frequently conversions between one format to the other. For example, from CTAB to SMILES, or from CTAB to INSI, or canonicalization of SMILES, or calculation of properties. So typical functions that people do very often in Bioinformatics. So what we try to do with these services is to wrap these into web services. So again, this is a live documentation page. You can see all the different methods that are available. If you click on a link, you will see, let me find one. So let's say CTAB to SMILES conversion, for example. You'll find the description, and then you can paste connection table here. You can click get, and you can get back the results. There is one that I would like to use actually. So there is the image to smiles, let's say, method here. So this uses OSRA. OSRA is a tool that does the image to structure conversion. This is also included in myChEMBL. So what I'm going to do here, I'm going to use this to do my own image to structure conversion. I have an image stored on my desktop. It is the image of aspirin. So I can drop it here and then click post. And then I get back the smiles, the corresponding smiles of the structure as it was converted by OSRA from the image. And that's an example of how you would use these web services in order to get access to different cheminformatics tools, but without having to worry about installing or maintaining these tools. Just you would only have to call these web services. Going back to the Launchpad, the other way to access the data in a more programmatic and automated fashion would be KNIME. So KNIME is another workflow tool which you could use to connect with myChEMBL. And for that we have a workflow available. So you can go to the link, download the workflow, and then import it to your KNIME application. So this is what I did here. So this is a way to access data from myChEMBL directly. So you can do this either via a direct database connection or by just calling the web services that are available in myChEMBL. So in the first example, you can just write arbitrary SQL. Here I'm trying to do substructure search using the notation provided by the RDKit cartridge, and this will run against the Postgres database in myChEMBL. So this is my substructure, my pattern, and then I can get back all the hits against the data in myChEMBL. And I guess you see that KNIME is convenient because it's got its own table previews and its own structure rendering, so it's really easy to visualize the results. And the other way to do similar searches, so either chemistry searches or fetching bioactivity data for any compound, target, or assay, would be to use the web services that I've just described, but you can call them from KNIME. So again, what I do here is I submit the ChEMBL ID that corresponds to a target, and then the web services will go and fetch the data from myChEMBL, all the bioactivity data that are associated with this particular target. And again, the results come tabulated within KNIME. And of course, KNIME is very good at filtering further processing of the data, so filtering, joining, sorting of the data in order to create the workflow that you want. Okay, and the last thing that you can do with myChEMBL, if I go back to my slides, back to the web page, is the iPython notebooks. As I said, we provide, I think, 12 iPython notebooks, so tutorials, interactive tutorials that you can go through and you can change and you can re-execute. And the topics range from introduction to cheminformatics, let's say, and introduction to querying databases, to more advanced topics such as machine learning, plotting, web application topics such as how to use the Django ORM, how to process and mine data that come from ChEMBL, which is our pattern chemistry resource. So a wide range of tutorials here. So I will just start with the introduction to myChEMBL. So this is how an iPython notebook looks like. So you can combine code, the results of the code, further annotation and markup, like different headings and links. And then if you scroll down, you'll see also renderings and images of structures. And this, you can export it as a text file, and you can host it online, put it on GitHub, or send it to a colleague, and your colleague can render and go through the same exact steps. So this is an example of literate programming. And as I said, this is live and dynamic. So if I want, I can change this and execute this cell, and this will change automatically. And what I have here is a gentle introduction to cheminformatics processing using RDKit. So this is a smile string, which is converted to a molecule in RDKit, and then you can calculate ChEMBL descriptors for this molecule. And then this is the mol file of the same structure. You can calculate coordinates, 2D coordinates, and add them to the mol file. You can calculate a fingerprint and visualize it again here. And then you can do more, I guess, sophisticated things, like you can calculate the similarity maps between two structures. That's a functionality provided by RDKit. Or you can then do a smarts-based substructure search against the ChEMBL database using Python. So this is our smarts pattern. This is a way to visualize the smarts, and then further on, you can execute the query against the database, and then you can also use pandas to tabulate your results, tidy up the results, do some table logic, filtering the results using pandas, basic plotting like histograms and scatter plots, etc. There are other examples. So we have a comprehensive example of how you would do machine learning using cheminformatics data, so both classification and regression on another iPython notebook. So how you would read the set of data, calculate fingerprints and descriptors, and then examples of how you would do naive Bayesian classification, for example, generate plots, ROC plots, and precision recall plots, and also use random forests in addition to naive Bayesian analysis. And then moving on, it will move on to regression. And again, you have plots, and also you get the model interpretation, so which descriptors or fingerprints contribute to the model predictions, for example. There is another one. So there's the predict targets tutorial. So talking about reproducibility. So we have generated models that were trained using the ChEMBL data and given a new structure and coded as smiles. They can give a ranked list of predicted targets for this molecule using a chemogenomics method. So we share these models, and we also have this tutorial that shows users how to use and take advantage of these models. So you can import the models, submit your smile string, you can visualize the resulting compound, and then you can get a list of predicted targets for this structure based on the data learned from ChEMBL. And you can also get the contribution of the individual features and substructures to these predictions. So I think that was the end of the live demo. So if I go towards the end of my slides here. So talk about this. So coming soon, there will be a new release of myChEMBL very soon, probably within this month. So it will contain the new release of ChEMBL, that is ChEMBL 20. And will also contain a new version of the web services. So the web services that we use in the main ChEMBL webpage have changed. They are now significantly improved. So what we're going to do is we're going to mirror these web services to myChEMBL as well. So myChEMBL and ChEMBL will have the exact same web services. Other updates include the Python libraries and RDKit. So we're going to use an updated version of RDKit, the current stable version. And finally, there's going to be an installation script for CentOS operating systems in addition to Ubuntu. So if people have CentOS machines, they can install myChEMBL there as well. This is the slide to acknowledge all the people who have been involved in the development of myChEMBL, and also all the open source and free software providers without whom myChEMBL wouldn't be possible. If you're interested in publications, there have been 2 publications in the last couple of years about myChEMBL. We have also been awarded a couple of prizes. So myChEMBL was the Bioinformatics Tool of the Year last year, nominated by the EPFL, and we also got another prize by the ACS in the field of neglected tropical diseases, drug discovery, training, and dissemination. If you would like to, you could follow our blog for updates on everything around ChEMBL, but in this case, specifically about the new release of myChEMBL. And finally, if you have any questions or if you would like to give feedback or ask for support, we have a dedicated email address at mychembl@ebi.ac.uk.